What is up, YouTube? And welcome to episode 48 of Chaos Daily. Let's get straight into it. So, yesterday we were talking about the changes that I want to make to the Albatross, because I have noticed a few things. Now, I've got the fuselage here all glued up, and you'll notice there's some broken bits. This is now a test article. This is not going to fly. I decided when I was going through the changes that I wanted to make and thinking of all the different changes that I need to make, and that I've done them. We'll get into Inventor just now, but I decided that this isn't good enough to fly. I'm not going to risk putting my hardware into this to go fly it and have it potentially crash and damage the battery, or damage the motor, or break props and wreck hardware and stuff. Not worth the risk. So, test article it is, which means I get to break this and to see how it breaks, why it breaks. Use that to inform design decisions for the upgraded version, which I've already done, which is why you see this. This was testing the torsional strength. There's quite a bit. Now, the other good thing to note is the way that it breaks. It's not breaking anywhere near the join seam. Wherever it's joined on that seam, it's not broken there. It's cracked everywhere else, and it cracks in longitudinal ways. That's because I don't have enough lateral strength, which is good to know, because that means that the decisions that I've made to change in the new version are correct. I've also beefed up the height of the internal structure from a 2mm flange that goes the spiral pattern. It's now 3mm flange. As well as a number of other changes, and we'll jump in Inventor just now and have a look. But I'm super satisfied with the strength of the joints, even though this is shoddy work, because they didn't quite match up, didn't quite fit. But it turned out really well. Now, I had this comment on Flight Test Forums, because I made the post on the Albatross in Flight Test Forums, about the torsional rigidity for the motor is more than sufficient. And it's going to be even more so with the changes that I make. There's zero reason to go with a double wall thickness. At all. There was more than enough torsional rigidity. The issue I was facing was when these parts of the hatch bend outward or inwards. It causes the nose to bend up or down. That was the weakness that caused this crack, because I was testing this, and you can see there that's how that broke like that there, and then the crack formed and carried on. So yeah, the decisions I've made for the changes that I've done are validated. I've also noticed a few other things that I want to change and do different. On that subject of things that I'm going to change and do different, I also printed, along with the tail, by the way, this is really nice. This turned out really good. Some nice pictures here for you of it standing against next to a couple of doors. This turned out really good. What didn't turn out really well was the V-tail sections. And this looks like Swiss cheese for a reason. I forgot to put holes in the internal structure. You see all those lines in there? Right, so these cells, they're closed cells. So the majority of these were all filled with resin. So I had to go in with a pokey thing and try and poke small holes to drain out the resin. And it didn't work out too well. This is a mixture of Siraya Fast with 25% by weight Siraya Blue. Blue is Siraya sort of like hardening resin. If you add Siraya Blue to their fast resin, it makes the resin more brittle, makes it harder, makes it tougher, makes it stronger. But because it is more brittle, when I was trying to poke those holes, it looks like this thing's been through the wars and it's been shot up. So yeah, these were a failure. I must remember to redesign. I'd want to redesign all this internal structure anyways. It's too heavy. But as always, all the holes, perfect fit. And it all goes together just beautifully. Isn't that nice? Super happy with that side of things, but yeah, all this internal structure in this is going to change. I'm probably even going to print all of this with this as one piece instead of having to join them. This I'm going to try and keep the same, but because of the changes that I've been making, some of the things in the Inventor file have screwed up, so I'm battling to fix it. I was dealing with a number of crashes yesterday. And on that note, let us jump into Inventor and have a look at what I've done. Oogie doogie, let's have a look. Right, first up, like I mentioned, I've increased the height of these spiral flanges. They're now 3mm. It's a little bit thicker. And I've also changed the pitch of the spiral. They're a lot less drastic. Much closer than 45, but not quite. They're still a bit more longitudinal than they are lateral. But that works sufficiently because I have also added lateral stiffeners, ribs along the full length of the body. As well as that, if we jump into here, if we just hide that, and we come in and have a look here, you'll notice that these holes around these flanges. These are now the joining flanges. These are separate to the stiffening flanges. So there's more flanges. Flanges is a funny word. And there's holes on this section as well. So now if we open up, minimize that. If you come in and look in here, I've got now these register little nibs, little tenons, little things that they fit in the holes on the corresponding side, and they're all toleranced to fit. So there is a 0.1 mil gap around them in the hole so that they fit nicely, and they're all going to work nicely. What else? The hatch is all one piece now. It's not two separate pieces, so I won't be joining the hatch. The hatch just gets printed as one. That's going to be printed next. And the nose piece, the hatch middle fuselage, the wing root fuselage, and the tail, they're all getting printed now. They're all on the print bed all in one go. Would you like to see what that looks like? That looks like this. And I've learned my lesson about clumping stuff up. Each one has its own raft, spaced separately, and I can remove the support material much easily. Now, I like Lychee. It's more stable. It runs more smoothly. It doesn't crash like every 5 minutes. The issue I have with it, though, is the support materials. The auto-generate support material and stuff like that, it sucks. It just straight up sucks. There's something about it that doesn't work the same as in Shitterbox. And Shitterbox has this neat little feature where you can auto-generate supports and you can click on platform only or the whole model. And this is important especially for stuff like for this one here, where I just want to generate supports that are touching between the model and the platform. I don't want to generate supports on the inside between the model and the model. It's like Lychee just doesn't seem to have that feature for some reason. I don't understand why. It's a really important feature to have. But yeah, so I've actually come in all of these supports manually placed. Every single one. I've manually placed all of these supports. So yeah, I'm not happy with the support features in Lychee. I hope they fix it. I really do. But yeah, so this is in the print at the moment. This is getting printed. And I have to reprint the hatch because the way that I had it supported in the Lychee software didn't really work too well. I was not happy with it at all. So I've redone it here in Chitterbox and done Chitterbox support material. The way that Chitterbox lines up its supports is important. Lychee seems to have this sort of weird ISO grid random auto-generate system that it uses. It's terrible, to be honest. When you're doing large surface area parts like this and you're trying to peel the part away from the support material, having linear arranged supports is very handy. Because as you're peeling, the forces that you apply to it to break the supports is a linear progression. Whereas if you've got this weird ISO grid, you end up with clumps of stuff that's all in weird places. Here, let me go get you the failed print and show you. So I've got it here, right? This is just awful. Look how it clumps them. It's got weird spacing where there's nothing going on. And then in other places, it's just support bonanza. I really don't understand it. There seems to be there's no system in Lychee that tells each support to be a certain distance from another support. I really think they should use some system like a Boyd system. I don't know what the correct programming terminology is, but I just know how Boyd's use. Boyd's is like a simulation system for calculating the movements of flocks of bird or fish, for replicating that kind of movement or separation of multiple things. Now, if you use that kind of group separation algorithm to separate your supports so that you don't have them clumping up in these terrible ways, and you get a much more even and linear distribution of supports, would be a lot better. Luckily, this was only 5 hours to print. It's a mess. And I looked at it in slicing in Lychee before I printed it, but it's so hard to tell with the way that it's all just bunched up. You can't really get a good idea of how bunched up they are. It's too much noise for the eye to take in and look at, and then for you to process. To be honest, I should not have printed this. I should have looked at it and gone, no, that's garbage. I'm not going to print that. So yeah, you can see the comparison of how Lychee does its support materials and how Shitterbox does its support materials. So all in all, pros and cons everywhere. Shitterbox is still shit, and Lychee Lychee's great. Like, I love working with Lychee, but there's some back-end stuff that they need to fix, especially in the support material department. This is terrible. Like, there's no uniformity to any of this. It's just almost random. So I hope they fix that. Anyways, back to Inventor. Right. So let's see what else I've changed. Added some like holes through this internal structure. I've thickened these up as well. These are now 1 mil. It's a little hard to see. Let me untransparent this. I've now thickened these plates. These are now 1 millimeter thick, and I've also added these sort of. There we go. So I've also added these sort of these slots to reduce some of the weight in here. So they're still just as strong, they're just going to be much lighter. Because I've added all this extra weight with increasing the height of these flanges. I've also thickened the material on the servo mount, so these are going to be less wobbly. Filleted at the bottom so they're better support on the base. I've changed the layout of the support for these Bowden tubes. I remembered the name, Bowden tubes. That's what they're called, Bowden tubes. Yeah, so now this is just a single flange that runs all the way along. I'm thinking I might cut some holes in the back here, but I've already started the print, so it doesn't matter. All up, this weighs the same. Can you believe that? I don't think you don't believe that, do you? This fuselage, with these changes, made it thicker and stronger in places and stuff like that, is the same weight as the previous version. A lot of it comes down to the flanges on these Bowden tubes. There's less of these fins in the servo mounts. There's now just 3, whereas there were 5 before. Yeah, I think that covers it. Yeah, just added more flanges, register tabs to slot everything together. Same with these sides here. You can see them sitting there. Yeah, that pretty much covered it. So next up, I will start working on the tail, which you can see here, the sweeps for those Bowden tube things running through to the back, as well as like all the stuff. It's all messed up. I need to go in and fix stuff. But it's a bit of a slow slog because yesterday I got to just about finished with this, and then I started working on some cleanup, just removing some of the old operations that I had in place to do stuff, which I don't need to do anymore because I've changed the way things are done and actually improved stuff. But removing those operations caused Inventor to crash every time I removed them, and then tried to save the program. Inventor just crashed for some reason. So I don't know what's going on, but we'll figure it out today. So there you go. Nice and simple. Things have changed. I said I'd change stuff, but I've changed stuff. And it's that easy. I love my job. I really do. This is so much fun. I can't wait to go pull those prints out tomorrow. I'll probably bring you along to that. So tomorrow's episode is going to be a little bit later than normal. I have an interview with YouTube mentorship group called Jumpstart YouTube or something. It's run by Daryl Eves. So hopefully I can figure out what's going on with my YouTube channel and get things to move along a bit better and get some more traction, get that subscriber count up. Not that that's important, but it kind of is, because you guys are awesome. I love you. But I want more of you. I'm greedy. Hey, we all are. You can't fault a guy for that. And wouldn't you agree it would be better if more people knew about the stuff that I'm doing? So anyways, yeah. So that'll cover it for today's episode. Make sure you've hit the like button if you haven't. Make sure you've subscribed. If you're not, go check out my Patreon if you can. These projects are not cheap, but it's super helpful if you do. And as always, I've been Chaos. And until next time, expect the unexpected. And I will see you guys later. And a special thank you to all my patrons that help support the channel. If you would also like to support the channel, there's a link in the description.